All right. So it looks like we're over here. I will finish lecture pretty soon today. There isn't that much for me to go over, frankly. Okay, so I will do that one law of sines problem where we had to do two different triangles. That might take a little while, but not that long, I hope. And then a couple word problems, then I'm finished. Okay, so the rest of the time, you can ask me questions in preparation for the test the rest of today and also tomorrow, and then Friday's the test. So it's been a long time since we've had an exam, about a month, but you know the way it works. So I keep switching back yellow and white here. All right, so you submit the homework. All of this, there's a 70% requirement. You must submit at least 70% of the homework. But hey, I end up doing what? Sometimes half of the homework, or a little bit more than half, or even if it's a little bit less. That really means your 70% ends up being only, 30%, 40%, something like that. Okay, so coverage is all of this stuff. So around 9:01, 9:02, I will send you the test via Canvas announcements, but I'll also project it like this for those of you who prefer this. And you can have your one cheat sheet, so write whatever you want, front and back. You don't have to submit that. Okay, and what else? During the exams, you have your camera on. You must have your camera on so I can see you, that there's nothing weird going on. But mute yourselves, obviously. If you have something to share with me, then put it on the chat. If you finish early, then just leave. Okay, then I'll close the class at the usual time, which is 10 o'clock. And then I'll close up shop. Then you have 5 minutes to submit the exam. So take a picture on your cell phone of all your pages of your test. Or if you have a scanner that's preferred, like Cam scanner, it comes out nicer. And then you have until 10:30 to submit the homework. But again, if you want to submit the homework early, some of you do, then that's perfectly fine also. Okay, and what else do I need to say about the test? And so the questions are just like the homework. I think you've seen enough of my exams. I don't give trick questions or surprise questions. For the most part, everything is just like the homework. So if you can do the homework, you should be okay in the test, right? Okay, and a reminder, I added in one problem 18, but I ended up doing it anyway, right? So not really that big a deal. And looking ahead, we really don't have that much left in the course. The next exam, there's only 3 sections, and I think that's just about as short as, yeah. And then the one after that is only 4 sections. Okay, so looking ahead, we have another exam on the 20th, only 2 weeks, but there's only 3 sections. Yeah, that includes a holiday. There's a Veterans Day holiday. And then we only have 4 sections. That passes through Thanksgiving, but we should have plenty of time to finish up for the last exam. I'm not sure if I'm going to change this date for the last exam, but we'll see how it goes. Okay, then all we have left after that is a final exam, and we're done. Okay. All right, so I'll be done probably early today, so be prepared for a question and answer session afterwards. And if there isn't anything, then we'll just dismiss and we'll be done. Okay. All right, so now let me tackle problem 15, where it says there are 2 solutions. Solve for the missing parts of the triangle satisfying A is 125, B is 150, alpha is 55. There are 2 solutions. So why would there be 2 solutions? And that didn't happen to any of the other ones. Okay, so first, can I use law of sines for this one? Now, we prefer law of sines. It's usually a little bit easier. Okay, I got A, B, and alpha. They give me A and alpha, same letter, so that means law of sines will work. Okay, so you got what? Sine of alpha over A, sine of beta over B, sine of gamma over C. In order to use the law of sines, you must have 2 of some letter, A with A, alpha, B with B, beta, or C with C, gamma. Okay, we do, so that's what's going to happen there. Okay, so let me switch over. All right, so temporarily ignore the red. Those are the answers. They give us alpha is 55, A is 125, B is 150. Okay, set up law of sines. Notice you have all the information right here because you have A and alpha. That's going to help in cross multiplying. Sine of 55 degrees over 125 equals sine of beta over 150 equals sine of gamma over c. Notice I don't have anything for c, but that's okay. I would temporarily ignore this. Based on this information, I can find beta, right? And once I find beta, well, that means I'm going to have two angles. Anytime you have two angles, you can automatically get the third, right? Just go 180 minus the sum. And then once I have that, I can figure out C. Okay. All right. So cross multiply, that seems normal. 125 sine beta equals 150 sine of 55 degrees. Divide by 125. Okay, so sine of beta is 0.9830. Okay. Now, here's the tricky thing about it. Sine of beta is 0.9830. So beta is sine inverse of 0.9830, which is 79.41 degrees, but that's only one possibility. Okay, so we talked about that. It's a little bit tricky. I get a little scratch paper here. So the sine of the angle is 0.9830. That means the y coordinate. So if I may digress a moment again. Okay, we've got this, something 0.9830. The y coordinate is 0.9830. So what is the angle? 79.41 degrees. So this is 70, whatever it was, 79.41 degrees. But there's a second quadrant angle that would also work by symmetry. This will be just as high. The sine of that angle is also 0.9830. Okay, so the angle in standard position here would be 180 minus 79.41 degrees. And that comes out to be 100.59 degrees. So that leads us to two possible triangles. Okay, so it's a little bit tricky. Okay, so one more time, I got to here. Sine of beta is 0.9830. There's actually two angles that will work. Your calculator is only going to give you the nice angle, the first quadrant angle. 79.41 degrees. But there's a second quadrant angle that also works. Okay. By symmetry, this would be 79.41. So to find this angle in standard position, I would go 180 minus that is 100.59 degrees. Okay. Now you might say, well, how come I don't have to worry about that before? Okay. There was actually a case in a previous problem. I just kind of slid through it. But if you did that same trick, you would surpass the quota of 180 degrees. Okay, so, and you know you can't go past 180. So if you go past 180, then you have to throw that out. So let's suppose this second angle, see 55, suppose the second angle came out to be 130, right? Then you go 130 plus 55 is 185. Oh, that's already past 180 degrees, not possible. So this two possible triangles doesn't happen. Or it might violate the idea that the largest angle is opposite the largest side and the smallest angle is opposite the smallest side. Maybe that got violated. Okay, and so we never had to worry about it before. Okay, so this seems to be our only case. So if I go 100.59, I'm still within my limit. 100 plus 55, I'm still within my limit. Okay, so that's the reason why you end up with two possible triangles in this particular case. Okay, on a deeper scale, this gets deeper than I really care to too much. But in your high school geometry class, this is a side, and an angle. Okay, there was no side-side angle congruence in high school geometry. Okay, there was a side angle side that determines one triangle. There was an angle side angle, but there was no side angle, which is what we have, side angle. So there does not have to be only one triangle. Okay, so I have two cases. I just worked both of the two cases out separately. Okay, so I found the two angles for beta to be 79.41. Got that one there. Or 180 minus that, which is 100.59. Okay, so that's why I have two possible triangles. And now I just work the rest of the problem out the same as usual. Okay, so this one is 79.41 degrees. But we now agreed beta could also be 180 minus 79.41, 100.59 degrees. So 100.59 degrees. Okay, so I have to work the problem out twice. So there are two possible triangles. Okay, now you can see what happens after that. Now that I have alpha and beta, right? It's easy to find gamma, 180 minus the sum. Same thing here, 180 minus the sum. So switch over to the law of sines to figure out little c, and then I'm done. Okay. So to finish up the problem, case 1, beta is 79.41. Okay, I got 55, 79.41, and then I just go 180 minus their sum. Okay. And gamma comes out to 45.59 degrees. Okay. So I go 180 minus the sum of these two. Okay, 45.59 degrees. So now that plus that is 180. Okay, so gamma is 45.59. Then I can put 45.59 right here and go back to my law of sines. Okay, so I decided to use sine of 55 over 125 equals sine of 45.59 degrees divided by c. Okay, going back up here, eliminating that middle fraction, I'm using this. Okay, and by the way, for greater accuracy, you should always use a given number rather than a derived number. Okay, beta is certainly a rounded off number, 79.41. So since it's rounded off, it won't be as accurate as using a given number at 55. So always use the given information whenever possible. So sine of 55 over 125 equals sine of 45.59 divided by c, and that's what I have over here. Okay, the rest is fairly ordinary. Cross multiply. C sine of 55 degrees equals 125 sine of 45.59 divided by sine of 55. And there we go. Punch it in your machine. Make sure you were in degree mode. 109.01. Okay, so we have it. So case 1. Okay, again, what does it mean to solve for a triangle? You need 3 sides and 3 angles. Normally they give you 3 pieces of information. You just give the other information. Okay, so that means even before I start this problem, I know what my answer is going to be. See, they give me A and B, but not C. So I'm going to say C equals blah, blah, blah. And they give me alpha. And then beta equals blah, blah, blah. And gamma equals blah, blah, blah. Right? That's how I'm going to list my answer, even before you start. Okay, so solve a triangle means give all the sides, give all the angles. They normally give you 3 pieces of information. So just list the others. So what I need are C and what? Beta and gamma. Okay. So there we are. C, beta, and gamma. So C is 109.01. Beta is 79.41 degrees. And gamma is 45.59 degrees. And do likewise on the exam. Okay, so if you're given 3 pieces of information and you're asked to solve the triangle, then list at the very end everything, so it's easier for my eye to pick everything out. Okay, rather than just guessing, oh, you got your answers all here, but I have to search around. Okay, where is it? Where's beta? Where's gamma? Right? Okay, I have listed it on this triangle. Okay, but to make things easier on me, I want you to list it like so. Okay, so in my teaching demonstration here, I've got in red the new stuff. Okay, so the given stuff is 55 degrees and 125 and 150. Okay, the derived stuff, the stuff that I've had to figure out, are the stuff in red. So C, beta, and gamma. So now you can see the triangle solved. I now have 1, 2, 3 sides and 1, 2, 3 angles. Okay, so that was case 1. And now for case 2, same thing, but remember we said beta could also be 100.59 degrees. So this is case 2, beta is 100.59 degrees. How did I get that? Again, it's 180 minus 79.41. Okay, that's based on this picture. There are 2 angles whose sine comes out to be 0.930, 79.41 degrees, and also 180 minus 79.41, or 100.59 degrees. Okay. But again, that might not be possible. You don't always have to have two triangles if, again, you've exceeded your 180 degrees, right? Like if I add these up, oh, I'm already past 180. Okay. Or something is violated, like the largest side is not opposite the largest angle, or the smallest side is not opposite the smallest angle, then that also means impossible. Okay, so now I just completely ignore this part, start a brand new problem, as it were. And so beta is 115.59. And the rest is easy. Now that I have these two, again, you can just subtract 180 minus the sum, right? So 180 minus that plus that comes out to be 24.41 degrees. And the rest works out exactly the same. Okay, so again, ignore the middle fraction. So sine of 55 over 125 equals sine of 24.41 divided by c. And again, cross multiply. That times that equals that times that. So c sine of 55 degrees equals 125 sine of 24.41. Divide both sides by sine of 55. So c is all that. Punch it in the machine, and you get 63.06. And there we go. So again, I haven't read the new stuff, so just categorize it right here. So C is 63.06, beta is 100.59 degrees, and gamma is 24.41 degrees. Okay, so there are two cases for this particular problem, as you can see. So definitely a lot more work. Okay, so here we are. And let's see, just noticing something here, if it's still consistent with everything we have. Let's see, largest side, largest angle. And smallest with smallest, correct. But that changes over here, maybe, let's see. Largest side, largest angle, that's still correct. And smallest with smallest, yes, that still fits. Okay, so largest side is opposite the largest angle, smallest side opposite the smallest angle. Okay. All right, so we finally finished that problem. Took me 20 minutes to do that, but that's okay. We're done with that. So 2 word problems, and then I'm done. 23 and 25, in which case afterwards, get ready to ask me questions, and if not, we're done for the day, folks. So 23. Somehow I don't have this correct here. My notes seem to be different here. 2 ships leave a port at 10 a.m. Ship number 1 travels at a bearing of north 62 degrees east at 20 miles per hour. Ship number 2 travels at a bearing south 75 degrees east at 25 miles an hour. How far apart are the ships at noon? Okay, and for some reason, I don't have the same problem here. So I might have to start from scratch on that one for some unknown reason. Let me come back to 23. Yeah, it looks like I have to do that separately. Okay, it's going to be a little bit longer than I thought. So let me go to 25 instead. Okay, sorry about that. 25 shouldn't be too bad, I think. So the National Forest Service maintains observation towers to check for the outbreak of forest fires. Suppose 2 towers are at the same elevation, one point A and the other 10 miles due west at point B. Okay, so here's A and B over here. The ranger at A spots a fire in the northwest whose line of sight makes an angle of 60 degrees with a line between the towers. Okay, so this is 63 degrees. And the other ranger over here sees that this angle is 50 degrees. And they're 10 miles apart. How far is the tower from the fire at point B? Okay, so I was able to draw this picture like so. So 50 degrees, 60 degrees, 10 miles, find X. Okay. And again, this is a practical use. You want to find the distance, but you don't really want to walk up to the fire unless you want to get scorched or something like that. Right? So forget that. So 50, 63. I can find this angle easily, right? Anytime you're given two angles, you can find the third. So 67 degrees. And now I can just do my law of sines, it looks like. I'll just go opposite. Sine of 63 over x, sine of 67 over 10. And there we go, right? So sine of 63 over x, sine of 67 over 10, cross multiply, x sine of 67 equals 10 sine of 63. Divide both sides by sine of 67. So 9.68 miles. 9.68 miles seems to be the answer. Okay, now let me see if I can tackle 23. It might come back to this picture, but I'm not sure what happened here because that's far from what we see here. All right, so let me try 23. So let me try to draw a picture of this more. Okay, ship number 1, north, 62 degrees east. So 62 degrees north of east. .62 degrees north of east. Let's see. North 62 degrees east. That's normally not the way that's interpreted. North 62 degrees east, 62 degrees north of east. It should be east of north. You know what I'm going to do? I'm going to skip this problem. So if you already did it, great. But it's more confusing than I thought it was. Sorry about that. Okay, so let's throw out problem 23. That's an easy remedy. You probably realize, it's one of the advantages of being a teacher. If you say, oh, I don't like the problem, I can just throw it out, right? You guys, unfortunately, don't get that luxury, but I can. So this should not be the case. North 62 degrees east means 62 degrees east from north, which is not that. Okay, so I'm going to forget about 23. I'm going to throw it out. So sorry about that. So in my notes, I think my notes is actually still okay, but I'll just cross it out and forget about that. Okay. All right, which means I'm done now, folks. Okay, so you may now start asking me questions about anything. And let me check the chat here. Okay. So let me look at the chat. Okay, so for problem number 15, do we always have to look for two angles? Yes, that's called the ambiguous case of the law of sines. Okay, so you have to look for two possible angles for the law of sines. You don't really have to for the law of cosines. For inverse cosine, it's an angle between 0 and 180 already, so you don't have to worry about that, only for the law of sines. Okay, and same thing, how do we know there are two solutions? Okay. I'm going to write something down here. But if you ever have side-side angle, I think I mentioned that briefly. So when do we have to look for two triangles? Okay. If you have a side-side angle combination, so let me show you something like this. Side, side and angle. Okay. Side-side angle, right? From your high school geometry, there is no side-side angle. That's where you might have to look for a second triangle, side-side angle. Okay. You don't have to worry about it for all the congruences that you had in high school geometry, like side, angle, side, 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 angle, side, angle. You guys remember stuff like that? Okay. This will lead to only one triangle. So if you see a side, angle, side, like this, I don't know, 14, 17, 20 degrees, side, angle, side, there's only going to be one triangle. Side, 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 7, 8, 9, there's only one triangle. That's a congruence. Angle, side, angle, there's only going to be one. So 30 degrees, 70 degrees, and the included side 4 or whatever. There's only going to be one triangle. Not for side, side, angle. Okay, so side, side, angle might have another triangle. It's not a guarantee, but you might have it. Okay, so that answers when you have to worry about the second possibility, generally for side, side, angle. Okay, so that's that. Okay, so now let me put down other questions. So number 19. Okay, somebody asked for number 19. I don't think I actually assigned that one. If you're talking about section 4.9. Yeah, 4.9, 19 was not assigned. So whoever's asking that, if you're asking for 4.9, we're not scheduled to do that one. Okay, so let me just write down other stuff. 4.7, 23, 4.8, 41, 4.4, 49, 4.7, 23 was already asked for, and 33. Okay, so let me get started with those. Okay, so I think I answered the question about the two possible triangles, most likely for side-side angles. Okay, and I think I'm caught up with the chat. So let me get started with doing these problems. But again, once I switch over, I won't be able to see the chat anymore until I'm finished with this. So get rid of the chat and start sharing again. Okay, so let me go in order, I guess. 4.449, somebody asked for. Yeah, I'm officially done with the chapter, so it's just questions and answers now. 4.449. Okay, determine if the function is even, odd, or neither. Okay, so 4.449. F of x equals absolute value of x, sine of x. So determine even or odd or neither, you replace x with negative x. F of negative x is absolute value of negative x, sine of negative x. Okay, now the absolute value of negative x is the same as the absolute value of x. Sine is an odd function, so the sine of negative x is negative sine of x, and I can put the negative in front of the whole thing, so negative absolute value of x, sine of x. Okay, now how does that compare with the original? It's the opposite. It's the opposite of the original function. So that qualifies the function as being odd. And I think that's all they asked for. Is the function even, odd, or neither? It's odd. Okay, which actually means origin symmetry, if you recall. That's what it means to be an odd function. You're going to have origin symmetry. Okay, 4.723 and 33. 4.723. Cosine of 2x squared, and the usual way I write it is like this. Cosine squared 2x. Rewrite it so that you only have stuff to the first power. Okay, so I'm going to use this identity. Cosine squared of theta is 1 plus cosine 2 theta over 2. So if you look at what I have over here, theta is like 2x. Okay, so if I go from here See here, I double the angle. Okay, so I double 2x. What is double 2x? 4x. So that means cosine squared of 2x is 1 plus cosine 4x all over 2. And I think that's it. Rewrite so that involves a summary difference of only constants and sine and cosine to the first power. Okay, so I'm going to have stuff to the first power. So that's pretty much it for that one. Okay. And then 33, verify the identity. Okay, so 33, tangent x minus cotangent x equals -2 cotangent of 2x. So tangent x minus cotangent x equals -2 cotangent 2x. Okay, so I draw my barrier that I know I'm not supposed to cross. So I'm going to work on this side, I'm going to work on this side, and hopefully I can get them to match. Okay, usually it's a good idea for stuff like this to change everything to sines and cosines. So this is sine x over cosine x. Leave a space, minus cosine x over sine x. Leave a space because I'm going to get a common denominator in a second. Okay, this one, -2 cotangent is cosine over sine. Cosine 2x over sine 2x. And each of these have their formulas. You can put them directly on your cheat sheet for the test. -2. So cosine of 2x is cosine squared x minus sine squared x. Sine of 2x is 2 sine x cosine x. Okay. And it looks like I can cancel these out. And now negative cosine squared x minus sine squared x, I can just turn these two around. So I'm going to rewrite it as sine squared x minus cosine squared x divided by sine x cosine x. So negative parentheses, something minus something, you can just turn them around. Okay, maybe I'll put a little sidebar here. The opposite of a minus b is b minus a. That's what I'm employing here. Negative cosine squared x minus sine squared x, I can just turn them around, sine squared x minus cosine squared x. So this is often useful. Okay. The opposite of something minus something, you can just turn it around. Okay. If you just plain out distribute, it's negative a minus a minus b, right? Negative a plus b, but negative a plus b is the same as this. All right, so I'm done with this side, and then on this side, the game is to get a common denominator. So this side needs sine x over sine x. This one needs cosine x over cosine x. And that pretty much does it. So I have my common denominator. So sine squared x minus cosine squared x over sine x cosine x. And now I can cut across. Kind of like lock and key. You can't cut across until you get a perfect match, and then you can cut across. Okay, so that's that. Side note again, maybe your trig teacher said you're only allowed to work on one side, then that's easy. Just put this statement over here, and draw that one down there, and draw that one down there, right? In other words, the steps would be step 1, 2, 3, 4, 5, 6. There it is. It's all on one side. Okay. Put step 1 here, step 2 there, step 3 goes next, step 4 goes next, step 5 goes next, step 6, and there it's all on one side, so to speak. Okay. All right, and 4.841, and that's the last one for that chat. So if nobody else has anything, then that's pretty much it. Let me see, 4.841. But yeah, you can go ahead and put other stuff. We still have 15 minutes or so. 4.841. Let me see what that one's about. So tangent of arcsine x. Okay. I'm going to put it way over here. It's almost like they're giving you the back of the book. And you don't really have to worry about all the other stuff. It's just to make it in a nice range, so to speak. So I'm not even going to use this information. It's the back of the book. Pretend it's not there. So find tangent of arc sine x. Okay, so I'll call this theta, which ultimately means I'm trying to find the tangent of theta. Okay, so theta equals arc sine x. Write it without the arc. Sine of theta equals x, which I'm going to write as x over 1. Right? So to rewrite without the arc, just put sine. Then you ask yourself, would it be reasonable if I take the sine of x? No, I'm taking the arc sine of x. So I can't be taking the sine of x. It doesn't make sense for a sine of x and arc sine of x to mean the same thing. So I must be taking the sine of something else. What else is there? Theta. Sine of theta is x. Okay, then I'll do my SOHCAHTOA. SOHCAHTOA, right? Theta. So sine is opposite over hypotenuse. So opposite hypotenuse. I need to find the adjacent. So temporarily call it, I don't know, y. X squared plus y squared equals 1. Subtract x squared, y squared equals 1 minus x squared. Y equals the square root of 1 minus x squared. Okay, so this is radical of 1 minus x squared. And now what do I want? Tangent. So tangent, TOA, opposite over adjacent. So opposite over adjacent, x over square root of 1 minus x squared. And there's the back of the book, so to speak. Okay. All right, I think I've caught up for this round, so let me check back the chat. In the meantime, what else do we have? 4.323. Let me write this down. And how much time do we have? Still about 10 minutes. 4.323, 4.831. Of course, you realize I can miss stuff. So if I miss stuff, ask again. You know, I'm trying to bounce back and forth between sharing, not sharing, look at the chat. So I might miss something. So if I miss your problem, I apologize. Just put it again, or you can ask again tomorrow. Okay, 4.323, 4.831. And I think I'm caught up this time. So 4.831. Yeah, okay. So let me try those. So back to sharing the screen, which means, again, I can't see the chat anymore. Okay, 4.831. Why don't I do that since I'm already in the section? 4.831. 4.831. Tangent, arc, cosine of 4/5. Okay, same thing. It's using the triangle stuff. Tangent, arc, cosine of 4/5. Call that theta. So ultimately, I'm trying to find tangent of theta. So theta is arc cosine of 4/5. Write it without the arc. Cosine. Okay, am I taking the cosine of theta or the cosine of 4/5? Cosine of theta. I can't be taking the cosine of 4/5. I'm taking the arc cosine of 4/5. It wouldn't make sense for arc cosine of 4/5 to be the same as cosine of 4/5. So it must be cosine of something else. 4/5. Okay. So draw my triangle. SOHCAHTOA. Cosine is adjacent over hypotenuse. Okay. You should recognize this famous triangle, 3, 4, 5, right? You guys know the 3, 4, 5 triangle? 3, 4, 5 is always a right triangle. 3 squared plus 4 squared equals 5 squared, right? 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. So if I see a right triangle, right, and I see a 4 and a hypotenuse of 5, automatically this is 3. All right, and what do we want? I want tangent of theta. So SOHCAHTOA. TOA, tangent is what? Opposite over adjacent. So 3/4. All right, and then what? 4.323. Let's see, 4.323. Okay, climber who needs to estimate the height of a cliff, blah, 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 40, 60, find the approximate height of the cliff. Okay, they pretty much give you the picture. And again, this is the practical use of trig. Okay, I want to figure out the height. I don't feel like climbing up here and getting a measuring tape and going down like that, right? I can measure this. That's pretty benign. That doesn't bother me. 40, and I can measure 60 degrees and go from there. Okay, so let me just draw the essence of that. 4.323, 60 degrees, 40. Find the height of the cliff. So that's x. Get my calculator ready. And make sure I am in degree mode. So mode, I am in degree mode. All right, so this is it. Find x without ever climbing this, right? Okay, opposite, adjacent. Sounds like tangent. Tangent 60 degrees is opposite over adjacent. Multiply by 40 and you're done. X is 40, tangent 60 degrees, which is approximately so many feet. Are we doing feet? Yes. Okay. So 40, tangent 60, 69.28. 40, tangent 60. Sorry if you can't see it, but you can do it yourself. Okay, so knock that one off. Okay, I think I'm caught up again. So anything else from the chat? I don't see anything else. What time is it? 9:55 almost. Okay, we don't have a whole lot of time left anyway. Okay, anybody else? Something quick? All right, we'll end today. So tomorrow you can have the whole time for asking questions. So come up with all your questions. But if not, I might just go ahead and start the next chapter. Okay, and then Friday's a test. All right, that'll be it, folks. So have a good day. I'll see everybody tomorrow. Okay, bye, everyone.